Okay, so very good day to everybody present here. Once again, we are back with the future of artificial intelligence. And today's session will discuss about AI in cotton production. Okay, that's our national need. And this is especially for you, my dear students and young researchers. And you can reach me at dr.christoananth@gmail.com. So before beginning the session, once again, let me thank God for giving me this golden opportunity to deliver this useful session to share my knowledge among my fellow national, international participants, students, and young researchers. In today's session, we'll have an interesting topic which is all about crop yield prediction with AI, and then we discussed about UAV, multi-spectral analysis, and then we discussed about sample collection and processing and how you try to process with AI, and about the remote sensing data collection. Then we collect actually the data with DJI Phantom 4 RTK and Phantom 4 multispectral. So that's a technology that we would be using in order to collect the data, and you should process the data. And then we have a training model, and then we discuss about the K-fold cross validation process. Okay. Yeah. Finally, we end this class with a Kahoot, and then we'll have also some videos to discuss the knowledge in our topics. So this is how you go with the crop yield production. Of course, in the traditional method, uh, we have been done with several processes to produce and then analyze the procedures. But of course, you need very intelligent decisions on the crop culture or maybe crop insurance, storage demand, cash flow, budget, and how you tend to go with the use of fertilizers and how you try to manage the water. So everything really matters. So everything has to be controlled. Only then the cotton, the raw product, is useful for the public or maybe the audience. So maybe with the case of traditional yield measurements, we need much more surveys. But of course, with the case of AI, it has its inbuilt services even. And for this we would use the unet segmentation network that's going to extract maybe that's going to recognize, and it is going to get real-time images. Okay, highly visible real-time images, and definitely we would calculate the BOP, ball opening pixel percentage. So with the case of the production, we will calculate this one. And of course we would be using the YAML, okay, back propagation neural network for this one, in order to find the pixel coverage of the cotton balls. So that's what we are going to do. So here we would have a UAV multispectral as well as insights even. So here we will be understanding or we correlating the non-linear relationship between the independent variables, and of course we will understand the correlations, we will understand the relationships, and of course we would go with the BOP calculation. Okay. So whenever it comes to cotton yield production, we have to go with the processing with the real-time images, and definitely with the analysis of real-time images. In order to combine this data, we can compare the performance of the neural network. So here we would be using a unit segmentation based approaches for the cotton ball segmentation recognition model, and we would be categorizing or maybe calculating the redundancy. Redundancy means reliability. Okay, how it is accurate, how it is performing according to the UAV images, and we would be going with a prediction map also. So how far the process may go. Okay, how much the performance you can compare with the existing process. So here we are going to compare with the breeding experiments even. We go with the data collection. So we go with the time series remote sensing data collection. Then we go with the RGB data, okay, the multispectral image, and then we go with the sampling of the field image data. Okay. Then after data collection, we go with the pre-processing. So in the pre-processing, we go with the image mosaic, we go with the registration of the images, and we go with the calculation of the spectral indices. Okay. After this, we go with the recognition and segmentation of cotton balls. We go with the label marking procedure. Then we go with the training of the models. Then we calculate the BOP, ball opening pixel percentage. Okay. So only after calculating the ball opening pixel percentage, then we tend to analyze this, this spectral images UAV models, and we can better establish this cotton for the production. So for the case of model establishment, we go with the modeling method selection, then we go with the data set production, then we eliminate the redundant variables. Redundant variables means repetitive variables that we would be eliminating them. And finally, we go with the production map, which is based on the model. So this is how the sample collection and processing is taken for. So we will have a wireframe where you define a boundary. Then you go with the sample collection, sample data. Then you go with a cotton ginning machine. And then you'll have the sample area example. Okay, so this is how you go with the collection of samples and processing of samples. This is a regional production chart where we tend to compare the sampling area and the production. So maybe you are able to achieve, for maybe 0, 20, 40, 60 up to 180, you will have the sampling image collection as well. So for this case, we would be using DJI. You can Google up for this one DJI. Dajiang Innovations Phantom 4 RTK model. It's a real-time kinematic model that you can use it for capturing the real-time multispectral images. Okay. So for this one, we use two types of drones. So they are equipped with the centimeter level navigation and ranging positioning systems. You can use it for this one with the integration of RTK, which is real-time kinematic model. Then we will have the GNSS, which is nothing but Global Navigation Satellite System. So we would be connecting with the NTRIP, which is nothing but Network Transport of RTCM via Internet Protocol. So over the routers, over the protocol, we were establishing stable performance with respect to the network parameters, and of course we are improving the precision accuracy with this model. So in order for remote sensing, we use this DJI Phantom 4 RTK model. Okay, so that is collaborated with GNSS, Global Navigation Satellite System. Okay. So this is how you try to collect the data with this DJI Phantom 4 RTK and Phantom 4 multispectral model. So it's a post-process kinematic model. It's not a pre-process, post-process model. So maybe you can calculate this higher precision position information through this DJI Cloud PPK model. So first is the DJI Phantom 4 RTK, and second is the DJI Phantom 4 multispectral for getting the multispectral data. And of course, you have a training model even. We will calculate the region of interest out of it. So here we will be using this NV tool for drawing the region of interest, and we will be analyzing at least 500 region of interest images or maybe regions, out of which maybe we categorize 400 are training sets and 100 are verification sets. So training sets, training models we will have, we inbuilt, feed the experiences, and of course we verify also. For that also we have some 100 verification sets. So this is the original image, and we draw the region of interest of the image, and we categorize the binary image, the digital image out of it. So this is the training set and validation set. So regards to the number of training and the losses, of course the loss is minimum with the case of training set, and of course with the validation set also. So as I told you, out of 500, 400 are training sets and 100 are verification sets. So this is the BOP calculation. Okay, so we go with the sampling area, then you go with the unit implementation approach. We have a class activation map, then we go with the image binarization. We get the binary image, then you calculate the mean, the average out of it, and we calculate the ball opening pixel percentage. So there are some code even. So we will have some supported funding model platforms. So we have GitHub, we have Patreon, we have Open Collective, we have Ko-Fi, we have Tidelift, we have Community Bridge, we have LiberPay, okay, we have Issue Hunt, and then we have Oteki, and then we have Custom. So these are the supporting funding, model platforms that we can use it in the industry or maybe manufacturing processes. So finally, we end with the K-fold cross validation. So we go, as I told you, we have training sets and for checking also, for verification also. So we have a data set, maybe for 100%, The data sets consumes 90% of it, and 10% you can go with the checking. Okay, so result 1 you'll get, result 2 you'll get, result 3 you'll get, result 10 you'll get, and you find the average value and get the result. Okay, so this is how you go with the collection of data, processing of data, and checking of the data.